Hello, we are Group 4 and our presentation focuses on the analysis of fraud detection in credit card transaction. Let's start off with the design thinking of our project. Our project will focus on fraud counts in the USA. Based on the snippet shown, strong growth in the US fraud detection and prevention market is forecasted from 2024 to 2033. With evolving fraud tactics, there is a growing need to pay attention to this market. Our project will focus on the analysis of the correlation of the following factors. 1. Customers' behavior data such as time of day of transactions, types of products or services bought, and transaction amount. Customers' demographics such as gender, geospatial data where we categorize the cities into states, and we aim to develop a machine learning model to detect potential fraud cases. Getting the data. Our group project hinges on a dataset from Kaggle. The tools we have used in this project are Tableau, Vice, Python, and Spark. Moving on to making the data fit for use. To ensure optimal data quality, we implemented a three-phase process involving data exploration, transformation, and enrichment. During the data exploration phase, we conducted a thorough analysis to address missing values, identify and manage outliers, and validate geospatial information. Following this, we standardized the dataset before addressing missing data, ensuring no imputation is used in this process.
So starting with missing value analysis, when it comes to missing data, we notice that some entries, particularly in the merchant zip code attribute, were incomplete. What's more significant is that certain cities like Tucson, El Paso, Austin, Houston, and Chicago had no data at all. So instead of trying to fill in these gaps through imputation, which could introduce bias, we decided to work with what we had. And by acknowledging the missing data, not artificially filling the blanks, we keep the analysis more transparent and avoiding making assumptions that could distort our finding. Next slide. So when looking at outliers, two regions stood out. One is Alaska and Hawaii. Starting with Alaska, we noticed much lower digital activity compared to other states. This could be due to harsh weather, which might disrupt internet connection and also the lifestyle. The people in Alaska might be less inclined to shop online, which could be the reason to less exposure to online fraud. This kind of missing data is what we call missing not at a random, because the reason for missing information isn't random. It's tied to these specific conditions. And for Hawaii, being a small island, had a unique case where each transaction appeared as a dot on the map of its cities. Due to its size and geography, the representation of transaction was quite different from other regions. Although these were significant outliers, we still decided to use the data as is to preserve the integrity of the analysis, accepting that these regions behave differently from the mainland US. Next slide. So now for geospatial information verification, to make sure our city data was accurate, we used latitude and longitude coordinates from the dataset and cross-checked them with city names. We used the GeoPy library to generate city names based on these coordinates. For verification, we temporarily created a new column with GeoPy generated city names, so we could compare them with the existing city names in the dataset. This column was just for checking accuracy. It wasn't included in the final dataset. We did encounter some challenges like rate limiting, which restricted how many requests we could make at once. To work around this, we used simple random sampling to extract a manageable subset of data for verification. So this ensured that we could check the accuracy efficiently without overwhelming the system while still maintaining high levels of data accuracy. Next slide. So next up is the standardization process, which plays a key role in improving data quality by making sure everything is consistent. Standardizing the data helps in ensuring that our analysis is accurate and that we can trust the results. First, we made some transformations like we added a stateful column to spell out state abbreviations. This makes it easier to interpret the data, especially in visualizations. We also added a country column, which really helps in when we are plotting data for different regions, particularly when we are looking at geospatial visualizations. On top of that, we cleaned up the dataset by removing unnecessary columns that weren't adding value to the analysis, such as first name, last name, and other details like transaction numbers and zip codes. Finally, we introduced some calculated columns to enhance our analysis like fraud count, total fraud count, and fraud percentage, which gave us a better view of fraud patterns across different regions. By standardizing the data, we are able to make it more organized and ready for deeper analysis.
Okay, I'm gonna talk about handling missing data. So in this data set, we notice missing zip code for merchant, which could impact our analysis. There is possible data is missing at not at random, meaning the certain pattern may exist behind missing entries. So the key approach to do that is the missing zip code could not have been fully processed during the data cleaning, suggesting the need for better filtering. Alternatively, we may use longitude and latitude to verify and fill in this missing zip code. By addressing this missing data, we ensure that analysis maintain accurate and reliable.
Now I will be presenting the section on making the data confess and visualization. The line chart shows the trends in credit card frauds over time hourly. The insight gives the information most number of fraud cases happens during 10 a.m. to 3 a.m. and the least cases are recorded during midday. Next slide. Now we will be analyze the correlation between transaction amount and probability of fraud. As seen from graph 2, the highest number of fraud occurrences occurs within the transaction range of USD 900 to 1049. This makes up about 60% of the fraud counts. Our team executed a Python script that generated Boolean outputs, returning true or false to indicate potential fraud cases. Following this, we conducted an analysis to explore the correlation between these results and relevant factors. Next slide. Now we will be analyze the correlation between types of products, services, bought, and fraud occurrences. The bar graph gives clearly shows that customers who perform transaction on categories such as groceries, online shopping of miscellaneous items have significantly higher risk of encountering fraud. Next slide. Now we will be analyze the correlation between gender and fraud occurrences. The correlation coefficient is 0.0071, showing that fraud is slightly more prevalent among females than males, though the difference is minimal.
In this slide, we will see the visuals of the both correlation and geospatial analysis between state and the fraud occurrences. Based on this analysis, we found that correlation between state and fraud count is about 0.038, which shows that there is medium association existing between state and fraud count. We perform geospatial analysis of fraud occurrences over state to see the density of over states. From the visuals, we can clearly see that states such as New York, Texas, and Pennsylvania have fraud counts more than 450, whereas states like Delaware, Hawaii, Idaho, and few other states report the lowest fraud counts, less than 20 cases. Now we move on to data storytelling. Listed are the key facts we collected based on our analysis. The percentage of fraud occurrences is thrice as many between 10 a.m. and 3 a.m., which suggests that fraudulent activity likely to occur during late night. It is better to avoid making transactions between 10 p.m. and 3 a.m., as fraud is more likely to occur during these hours. The percentage of women who fall victim of fraud is 1 to 2% higher than that of men. This shows that women may engage in more frequent online shopping or use credit cards more regularly for transactions, increasing their exposure to credit card fraud. We also noticed that 60% of fraud occurred at transactions amount ranging from US dollar 900 to 1049. Being cautious with transaction to this amount, as nearly 60% of fraud occurs in this range. Stay vigilant with larger amounts as fraud risk increases with transaction size. Next, we found that 15% of fraud higher in types of products like grocery and miscellaneous shopping. Grocery and miscellaneous items are everyday purchases, and this frequency can create opportunities for fraud. We also found that 28.5% of fraud occurrences were detected in these three states, New York, Texas, and Pennsylvania. These states have large population leading to more transactions and consequently a higher potential for fraud. Urban areas within these states, especially New York, contribute significantly to this trend.
I gotta talk about designing a machine learning model. So for designing a machine learning model, in our project, we began using a support vector machine, the SVM, with a linear kernel to predict the fault occurrences. As known in our first graph, we achieved the prediction rate very close to the actual fault rate, about 50%. Next, we improved the model by using RBF, which is Redis basis function SVM kernels, which allow us to better capture nonlinear patterns, which result a higher fault detection rate, increasing it to about 60%. So next slide, please. Oh, this is our presentation. Thank you for listening.